Well, good afternoon, everybody. My name is Roy Keeler. I am the Senior Product and Business Development Manager for Aerospace and Defense for AdLink Technology. I have the enviable position today of going right after lunch, the best spot in the lineup, I guess. So please, if you start falling asleep from eating too much, there's a test afterwards, so pay attention. We're going to talk a little bit about military signal analysis, meeting the imperatives of military signal analysis, and how the products that you see from AdLink and other vendors here will help us meet those imperatives in the future. Interestingly enough, listening to some of the other speakers earlier today, there's recurring themes that you hear here. Certain types of technology, where we're going, what we're trying to do, what we're trying to accomplish. So it was very interesting to me to hear some of the preceding pitches. So, data processing is an extremely important piece of today's modern military and aerospace and defense market. Signal analysis, spectrum analysis are keys to dominating the modern battlefield. And you're going to see this more and more coming up as we move into the next millennia here with aerospace and defense systems. So there were some obstacles in military signal processing and certain speed bumps. And one of those was about 15 years ago, manufacturers realized that they have reached the limits of processing speed. You get up to about 4 gigahertz and things start falling apart very rapidly. So we hit some speed bumps. What do you do, especially with CPUs? Well, they started looking at multi-core processing. Let's throw more cores at it. And again, you reach certain limitations, size, weight, and power. You can only get so much power out of a chip. As you can see, it peaked out here along this time frame. I can't read that, it's too small of eye chart, but you can see it did peak out. And we got some gains and then drawbacks and stuff like that. Then along came GPUs, and GPUs turned out to be a very efficient way to parallel process different sets of data. So now you can load data in, process it through really quickly. As you can see by the other chart in the green, processing started picking up rapidly with the introduction of GPUs and GPGPUs. So you're starting to get performance now designated by gigaflops per watt or gigaflops per second. So it really started changing the paradigm of processing for military systems. Some of the other obstacles that we see in military systems, size. Everything's getting shrunk down. Especially with the advent of unmanned systems, you have smaller and smaller vehicles. They want to be able to put stuff into different platforms that they're going to take out and deploy in the field. So we need to take a look as an industry at reducing swap, and everybody knows that. Everybody's taking a look at that too. Demands for nimbleness and mobility, they want to put these things in as I mentioned, in smaller vehicles. So it becomes small form factors become a very important part of our kit and our ability to provide them with the systems they need. Then you have issues of shock and vibration. Well, the nice thing about that is, in a way, back in the day when we were all doing VME 20, 25 years ago, shock and vibe was a very important consideration because we're using discrete chips and you're putting them onto a PWB, and it took a little bit of pixie dust and magic to get all this stuff to work together in the environments that we were facing. Nowadays, with systems on a chip type technology, that's really shrunk all of that down. You don't need discrete components as much. You don't have to worry about shock and vibration quite as much as you did then, because now you can pretty much seal these things into a brick. So that's changed the market as well. You also have GPUs now providing raw power right out the edge of the battlefield. So when you look at where the military is going, when you look at where defense market is going with this, power and virtualization out at the forward edge of the battle is very important. We're going to be facing that more and more as we design systems out there. So take, for example, this is one very good example of where you're going to see increased needs for processing power. You take a look at this imaging camera from Westcam. These are very sophisticated devices. One of these cost about $1.2 million. A lot of power in these things. You have 6 sensors in it right now. HD electro-optical and IR sensors. You're doing real-time target analysis and targeting. You have laser rangefinders, laser designators in these things. And this is all current state-of-the-art technology. You 720p and 810 or 1080p cameras. Well, what's going to happen now when the next generation stuff starts coming out? When you have 4K cameras in there, when you have many more processors. Let's say you have up to 10 different cameras on a system like this. Well, that's just going to increase the demand for processing power. And so these are some of the things that we're seeing that's coming forward that need these types of products that all of us are developing out here. When you start looking at these things, you start looking at processors. What processors are you going to pick for helping develop some of these systems? Well, central processing units, CPUs, or our processors we have in our laptops. We have processors in our cell phones running this thing, but they can't quite meet the demands of signal processing that we see out there in the market space. GPUs rose from the gaming market in the 70s, in the 2000s. Very capable, massive parallel processing. We were having a discussion at lunch here, and I recall back when I was in the university in the mid 80s that my sponsor, or my what's the word I'm searching for? My mentor in college, my professor, he was working on massive parallel processing, and he was taking 85 chips, gluing 64 of them on a grid, and trying to get to program those things. Very difficult, very difficult. And this was 30 some odd years ago. So it's come a long way. GPPs now are that extension of that early work trying to glue all these chips together. And then we have field program arrays, FPGAs. We've all used them, we all know about them. Very good at doing single things at one time. Very fast throughput. You want to do some windowing, that type of signal conditioning on the front end, that type of thing. But they're very difficult to program. They're not field programmable as the name would imply. You're not going to be able to go out there and reprogram in the field very easy. So they lent themselves for a different type of purpose. So that's why GPUs now we see are on the rise. For real-time signal analysis and processing, this is the chip turned out to be the chipset of choice, and not necessarily in NVIDIA. I just use that for an example, and plus that's what we are developing with at AdLink. But you have large video bandwidths or large bandwidths to be able to take a lot of data in and out very easily. The memory is close to the processor unit, so you're not doing so many fetches back and forth between memory and the processing unit. They're relatively easy to program. We have some advanced languages now. You have libraries, CUDA, C++, Python, ACC, OpenGL, all great languages for processing, for programming these devices. And you don't have to be an expert in these types of things to be able to program these. So in short, these processors really lend themselves to signal processing in this type of environment. So what we're going to do is take a look at some of the applications for GPUs out in the industry. So radar processing. One of the very big applications for GPUs is radar processing. And if you're keeping up on the news, what's going on in the defense community, the Navy just released a contract to Colorado Engineering last fall for F-35 radar. And the contract was to take GPUs and develop an F-35 radar system. So when you look at that, you can see that they're really embracing this technology, and they're really taking this out into the market, and they're going to be using it on our frontline defense systems. So all these applications can benefit from GPUs. So at AD-Link, we do offer a variety of different products for radar-type processing applications. Our VPX 3010 is a Xeon D-based 3U compact PC, or excuse me, 3U 3U VPX blade that is used extensively in that type of application. Also, the VPX 3G10 is a NVIDIA-based 3U blade that lends itself very well to radar-type applications. Next generation is coming. We're going to be going to a Quattro GPU, and depending on power requirements, it'll be something like either the P3000 or up to the P5000 series GPUs from NVIDIA. And you know, I know this is probably blasphemy for mentioning this, but compact PCI also. Very well suited for this type of application in less rugged type environments, so you could use something like that as well. Sonar processing is a very interesting application. Requires a lot of very intensive compute power, particularly on the sensor side and on the seeker side. You know, in most of our sonar systems today and in our torpedoes today, they use GPU and digital signal processing extensively. CBAS, for instance, the Mark 48 torpedo, actually uses VPX. There's a whole suite of VPX boards inside that particular munition. And if you're watching the news, the Navy is just announced, or actually DARPA just announced, what, 3 weeks ago, last month, their Ocean of Things initiative. And you're going to see more and more of this coming out. They're now taking a look at IoT, which of course lends itself very well to GPU processing, because you can do virtualization, you can do our AI out at the forward edge of the battle area again, and you're going to see more and more of this coming into play in naval systems, and in particular with this Ocean of Things coming out from the Navy. Image processing. You know, image processing is becoming increasingly important as well. And take, for example, if you're a military system and you're operating in a GPS access denied area, what are you going to do with your UAV when it's flying over some remote area and it loses GPS? How are you going to get that asset back? How are you going to get it to complete its mission? Well, that's where image processing can come into play. If you will, consider a device where you can store images, you have multiple camera inputs, the platform is looking at those cameras, bringing those images back, and comparing it to a map. So it can now geolocate itself within a GPS access denied area. So a lot of good applications for image processing out there, and there are a variety of very good products out there that will enable you to do that, and these are two of them, the high-power embedded computing products from AD-Link. So let's talk about communications too a little bit. You know, in network-centric warfare, they're really relying on interconnectivity between multiple devices through the global information grid and through the back to network-centric warfare. These systems need to be robust. They need to share information among themselves seamlessly. They need to provide situational awareness to the warfighter out in the field. And the speed is very, very important, because you're talking about people's lives here, how fast you can communicate. You need to get the data in the right place at the right time. So how do you do that? How do you get that type of communication system out into the field? It needs to be forwardly deployed, needs to be discoverable. Users should be able to access different types of applications within the system, right? Can be virtual machine based. Can operate disconnected, so you don't want it to be able to fall down if it just disconnects from the network. And you need middleware for data connectivity. And what we're doing at AdLink is contributing to that. We have a product, it's called Vortex, and it's based on Distributed Data Services, DDS. DDS is mandated by all new, by the DoD and MOD for all new communication systems that are coming out now, all new communication systems under development. And when you look at things like Command Post 2025, the Army's initiative to redo all of their command posts out in the field, and you look at also initiatives like the MOD's Morpheus program, where they're taking a new approach to the Bowman radios that they currently deploy in the UK. This all involves these elements and pieces of Distributed Data Service, or DDS. So what is DDS and Vortex? Well, it's a DDS, or Vortex, is an intelligent data sharing platform for mission critical applications. And what that means is it's a subscriber publisher service. It's a piece of middleware that runs in the background, and it allows data to be distributed throughout the network so that different users, depending on their level of access, can gain access to that data in real time. It gives you quality of service end to end. Dynamic discovery, you can connect and disconnect at will and come back on board. You can have temporal decoupling, so they can go out and operate independently and then come back in. And it's operating system and platform and hardware agnostic. So it doesn't matter what platform you're running it on, what operating system you're running it on, the software will run. It also has it's also built on open standards. And what we've just announced recently is that this is now a shareware type product. So it's a freeware. It's being offered now to developers, to whoever wants it, as a freeware type of product. So if you have, as a hardware vendor, as other hardware vendors here, if you have an interest in this type of product, please come up and talk to me sometime during these next 2 days. I'd be more than happy to give you more information on DDS, where it fits, and how you can become part of the open consortium on DDS. So, in conclusion, there's tremendous opportunity out there right now, especially in our field, and especially for these types of products. The military is changing how they're looking at things. I just read an article recently in the past 24 hours where now the Army is going to stop implementation of WIN-T, with looking towards the future of what's the next system, because they've realized they're behind in areas like EW and communications compared to our adversaries. So there's going to be opportunity for everybody in this room to take advantage of this with our products, and I think we would like to, and we are. AD-Link is helping lead that charge out there.